Okay, so let's finish up this section with the equations of parallel and perpendicular lines. So remember, y equals mx plus b is the slope-intercept form of a line, where m stands for the slope, b stands for the y-intercept. Sometimes, instead of giving you an equation and then you graphing it or anything like that, you're looking to write an equation given certain pieces of information, and we're going to do this in 3 different ways. First is the easiest. If they tell you, hey, we know that a line has a slope, we know it has a y-intercept, what is the equation? So in this example, the slope equals negative 3 over 5, the y-intercept equals to 7. And so we're just going to plug those 2 pieces of information into y equals mx plus b. So you get y equals negative 3 over 5x, because that's what this m is slope, plus 7, because that's the y-intercept. So that's the easiest case. And how these kind of work is each time you need one kind of new piece of information, and then once we figure some stuff out, it goes back to how the previous example was. So in this one, I'm going to give you a slope of 2, but instead of giving you a y-intercept, I'm just going to say something like it passes through the point 2, 7. And I've already labeled these as x and y. Normally I wouldn't do that at the beginning. So in this case, we know that y equals mx plus b. So we don't know what b is. We don't know the y-intercept, because I've been told. But we do know a y, which is 7. We know m, which is the slope, 2, and we know x is 2. So the steps basically is you're going to plug in the info you know, x, y, and m. Then you're going to solve for the y-intercept, b, and then you're going to rewrite as y equals mx plus b. Because once we find b, it goes back to how this previous problem was. If we solve for b, and we can basically just do this part again. So, as said, y is 7, m, the slope is 2, x is 2 plus b, which we don't know. Multiply that out, you get 7 equals 4 plus b. Subtract 4 from both sides, you get to b equals 3. And now it's just like this previous problem. We know the slope, we know the y-intercept, now we're just going to plug it in. So you get y equals 2x, because 2 is the slope, plus 3, because that's what b is. And we're done. So the extra thing you got to do is plug in the x and y on this one. The third type of problem you get is, I'm just going to tell you it passes through these 2 points. So now I haven't given you slope, and I haven't given you the y-intercept. So step 1, you're going to find the slope using that formula, m equals y2 minus y1 over x2 minus x1. Then you're going to basically follow the steps that we did in example number 2. You're going to plug in the info you know, x, y, and m. The difference is here is you can choose either point when you plug in. So on this one I had 2, 7. On this one you can choose 3, 3, or 6, 4 to plug in. So to find the slope, x, y, I'm subtracting this way to the left. 4 minus 3 over 6 minus 3. Y is on top because y rhymes with rise, and you get 1/3. So y equals mx plus b. I'm choosing to use the second point here. So y is 4 equals 6, that's x, times 1/3, which was a slope, plus b. And I wrote these backwards just because I like have the fraction second. I should have had 1/3 times 6. 1/3 of 6, you multiply straight across. 6 times 1 is 6, divided by 3 is 2. So you got 4 equals 2 plus b, subtract 2 from both sides, and we can get b equals 2. And get our answer, y equals 1/3 x, because 1/3 is our slope, plus 2. Now, just to show you, if I would have chosen 3, 3 instead of 6, 4, we'd have had 3 equals 1/3 times 3 plus b. 1/3 of 3 is 1. Subtract 1 from both sides to get 2 equals b, which is what we got before. So we get our answer, y equals 1/3 x plus 2. They're the same thing. So it doesn't matter which point you choose. Okay. So that's finding equations for line. The big part now is finding equations of parallel and perpendicular lines. So parallel lines have equal slopes, right? So you can't see my arms. You know, they're the same distance across. So slope is rise over run. So if this one goes up 3 over 5, if they're going to be the same distance apart each time, if this one goes up 3, so is this one. If this one goes over 5, so is this one. Because they're always that same distance apart, they never cross. So same distance apart, so the rise over run have to match is what I was trying to show you there. So we got a line, we got another line. This one goes up 1 over 5. If they're going to stay the same distance, this one's also got to go up 1 over 5. Or else they'll end up intersecting. So perpendicular lines, however, have opposite slopes. So another word for this is negative reciprocal, which means you flip whatever that number is and you switch the sign positive and negative. So see these red lines here and my little 90-degree mark, because if you remember, perpendicular means across at 90 degrees. This one goes up 5 over 6, slope of 5 over 6. If you flip 5 over 6 over, it becomes 6 over 5, and then you flip it from positive to negative, switch it from positive to negative. So this goes up 5 over 6, this one goes down 6 over 5 to keep that as a 90-degree mark. So if y equals 4x plus 7, a parallel line to it will have the same slope, 4. Right? If it has a slope of 4, a parallel line will have 4. A perpendicular line will have m equals negative 1/4, which is flipping and switching the sign. So remember, 4 as a fraction is 4 over 1. So when you flip it, it becomes 1 over 4. Then you change it from positive to negative. This is the type of question you'll have at the end. Find the equations of the line. Parallel, remember that's a symbol for parallel, and perpendicular, I guess it's that, to the line y equals negative 2/3 x plus 9 that pass through 6, 2. Graph all 3 lines. And that's just so you can kind of see if you did it right. This is just like the problems earlier. When I said the slope equals blank passes through blank. You just do it twice. Once for parallel, once for perpendicular. So it's like example 2 here. Slope equals something passes through something. So you need to use y equals mx plus b. Plug in the y and the x and the m for slope. You just do it twice. Once for parallel, once for perpendicular. So you can also try graphing them all first and then finding the equations from those lines if you want. It's another legit way. There is a third way, something called point slope form. A lot of people don't like it. If you're curious about it, it's actually a little bit simpler, but you just have to memorize another formula. You can ask me about it when we're together in class. So parallel. If something's parallel to this line, they have the same slope. So we know it has a slope of negative 2/3 and it passes through the point 6, 2. So we're going to plug that into the equation. Y is 2 equals m, which is negative 2/3, parentheses, times 6, because that's x, plus b. Negative 2 times 6 is negative 12. Negative 12 divided by 3 is negative 4. So that add 4 to both sides, you get b equals 6, and you get y equals negative 2/3 x plus 6. So just like we did a minute ago. For perpendicular, it's the same thing, except for we've got to flip and switch that slope. So flip over 2/3 becomes 3 over 2, and then switch it from negative to positive. So this equation will be what we use again, except for that negative 2/3 will just be a 3 over 2. 3 times 6 is 18. 18 divided by 2 is 9. So subtract 9 from both sides. You get b equals negative 7. And we get our answer as y equals 3 over 2x minus 7. And then I just graphed all 3 just to help you see. And you can kind of see if you did it right. So this pink line is our original. It's at 9. I guess I could have been zoomed in this whole time. Down 2 over 3, right? this one plus 6 down 2 over 3, down 2 over 3. And it said I had to pass through the point 6, 2. So I graphed the point 6, 2 to see if it went through it. And it did, right? So if you get an equation of your line and it does, and you graph it and it doesn't go through this point that it said it should, then you've done something incorrectly. So just make sure to check. What a lot of people do is go down 2 over 3, down 2 over 3, and they'll keep counting until hopefully it gets that point. And if you see, they do look parallel. And then on this last one, down 7, up 3 over 2, up 3 over 2, up 3 over 2, 6, 2, and it does look like a 90-degree angle. And that is it. Last section of this chapter. And then we're moving on to triangles.